Welcome back to the Wastewater Whiteboard, everybody. Today we are talking about the Venturi effect. And this is kind of an addendum to the video I did a couple weeks ago on pumps, where I talked about centrifugal pumps, airlift pumps, and positive displacement pumps, and I just totally glossed over Venturi pumps and vacuum style pumps, and I apologize for that. So here we are, we're gonna right that wrong, and I appreciate the viewer who actually pointed that out. Thank you very much. And I just want to explain the large part I actually glossed over it is I've not used a lot of Venturi style pumps in my career, and I don't use anything like it at my plant at the moment. I use everything centrifugal and positive displacement. So it was just an oversight. But thank you. If you ever think that I need to add something or maybe do an addendum style video, please put it in the comments. I really appreciate everybody out there commenting. And if you get anything out of this on that note, please like, subscribe, pass to your friends. Let's help folks get certified. And let's now talk about the Venturi effect. It operates off that Bernoulli's principle we talked about in that pump video I talked about. And I'll link to that at the end of this video. You can go watch that one. But in that, I talked about how a centrifugal pump's volute goes from a small to a large space, and it's moving water. And when that happens, due to the Bernoulli principle, the velocity slows. As the velocity drops, the pressure increases. Okay, the velocity drops because it goes into a wider area, a bigger area. There's more area, or more volume rather, but it's bigger. So in the Venturi effect, we do the exact opposite. We take a certain diameter pipe, whatever it is that we're using, and we constrict it into a smaller throat here. And then in this throat, what happens is the velocity increases and the pressure drops. It's the exact opposite of what happens in a volute, okay? And what we do here is we drop it to a pressure that we want it to be, that's conducive for whatever it is we are trying to do, okay? And I'll explain that in a second. And then afterwards, it goes into a wide chamber again, same diameter pipe that it was before, and the pressure returns to where it was at before, and then the velocity goes down. You go back to your original velocity, okay? And so the Venturi effect operates on vacuum due to differential pressure, okay? And there are four major things that you would use this for. One of them is gas scrubbing, like getting noxious gases out of something. And I'll explain how that works in a second. Aeration, you can aerate your activated sludge or whatever it is. You can use this as an aeration strategy. It's pretty cool. Chemical injection, and metering. Now, this is a wastewater specific conversation, but drinking water and distribution operator folks, you're going to be asked about the Venturi effect. Trust me. It was on my treatment exams, and the thing I was asked about the most was Venturi meters that I remember. So just know that. And not a lot, just knowing what they are and what they work off of. And that would be differential pressure. So, when we are using the Venturi effect to add something, when we're metering, we're not adding anything, but when we're adding something to it, in case we're like siphoning gas, like a nasty gas off of to go to a scrubber, or we're adding air, or we're adding chlorine, what happens is we want to, in this constriction, it's going to drop it to a certain pressure that we can, that should be lower than whatever it is we're putting in, okay? Now, atmosphere is typically standard atmosphere. This is going to be give or take relative to where you are, relative to the sea level, but 14.7 psi is standard atmospheric pressure. Okay, it's not measured in psi, it's measured in different units, but I'm just going to say it for the sake of our conversation here. And you use a manometer for that. If you look at how it's spelled, it looks like manometer, manometer. I should have written that, but that's a test question, by the way. You should know that manometers are used for pressure measurement. So anyway, yeah, as the pressure drops, if we are below atmosphere right here, 14.7 pounds, if we're under that, you could literally just have a hole in that pipe. And what would happen is it would suck air in. Okay, it's pretty cool. So like I use centrifugal blowers for my activated sludge plant, but this would be a great addition. If I had a pipe with enough velocity and low enough pressure that I could literally just have like a vacuum tube or something on here, and it would suck in air. That's a really great way to aerate. Very low cost. There's no electricity required except maybe the flow of the liquid. But yeah, it's pretty cool. Same with gas scrubbers. If you've got a noxious gas you're trying to get over to a scrubber, You can move compressed air through here. It doesn't have to be liquid. You can move air through here. And so long as it's under atmosphere or under the pressure of where that gas is, it'll come in. You know, I'm going to give you a couple of real world examples of Venturi effect. Drinking out of a straw. It's a pressure differential. You're drawing a vacuum. I make compost tea and I put it on my orchard. Okay. I hook my garden hose up to a Venturi style nozzle and I hook my, you probably used one of these before if you do any kind of gardening or chemical application even. And you hook your, whatever it is up. In my case, I'm talking about compost tea. I turn the water on and you can actually dial it into where the mixture you want, and it literally siphons it out. That's the Venturi effect. Venturi effect is using flight of airplanes. Like it's really cool and it's everywhere. It's all over the place if you start paying attention. But this is, again, specific to what we're talking about. Really, really cool stuff. And then chemical injection. So this injection point would have to be, again, lower PSI than whatever you're sending in. As long as that injector is a higher pressure than what's going on here, it will pull it in. Okay, it will for sure pull it in because it's higher pressure going into lower pressure. Now, in my case, I don't do this. I'll give you just a quick sneak peek, I guess, into our disinfection. And what I do here is I have an open chamber. And what I mean by that, it's like literally an open chamber of water that you could stick your hand in. And I have a chemical feed tube going into there, and it's strapped to a chemical induction pump. And chemical is injected and introduced below the impellers of this pump, and it mixes it around. I don't have anything cool like this. I've got literally an open box of water and a pump in there stirring things up, and I inject right into that channel. That's how I do it. Now let's talk about meters real quick, and we'll wrap this conversation up. So they're not going to be open to atmosphere. What they're going to be, and not usually anyway, what they're going to be doing is measuring the pressure differential between the upstream and the throat of the Venturi meter. So you got your pressure drop, you got your normal pressure, and then your pressure drop, and it knows how the diameter of pipe and all this stuff. And what it's able to do is calculate flow based off the pressure drop. What's really cool about Venturi meters is they're very low cost, not a lot can break, and what separates it against other meters is it is able to recover almost all of its pressure, so there's not a lot of pressure scrub. And why it's good for wastewater is we have a lot of solids content. You're not going to find a lot of nutating disc meters in wastewater. They get jammed up with crud pretty quick. I actually use mag meters in my plant. I don't use Venturi meters, but it's good for liquids like this. So yeah, any questions, please put in the comments. We're pretty much done. If you have anything to add to what I said, please put it in the comments. I really do appreciate people adding to the conversation and helping folks out. And with that is the Venturi effect in a nutshell. And yeah, we'll catch you guys in the next one. Have a great day.